Geometry, Unit 8, Section 5, the Pythagorean Theorem. It says up here, n special right triangles, but that is not there anymore. Those two sections used to be combined. We've just recently split them up into be two sections. So your next section is going to be special right triangles. This one is really just focused on the Pythagorean Theorem. And you probably don't need a video for this. You've been doing the Pythagorean Theorem probably every day in your math classes for several years. Pythagorean Theorem, we say a squared plus b squared equals c squared. But the most important thing is this is your hypotenuse squared, and these are the two legs that are being squared. It doesn't matter which one is which. The addition commutative property, so either leg can be in either order. It's not like the smallest leg has to be a and so on. And I don't really see this a lot anymore. In old Regents exams, they used to, try to trick students by labeling the triangle ABC, but then would say that, B is the right angle, which meant side B was the hypotenuse, not side C. So don't even worry too much about the lettering. I mean, these triangles aren't labeled A, B, and C. We just have to know that this is a leg, and this is the hypotenuse here. So don't get too caught up in the letters of it. Just know that one of your legs squared plus the other leg squared equals the hypotenuse squared. So there's common Pythagorean triplets. The common triplets are 3, 4, 5 is the most common one, and we actually see that here, 3, 4, so this would be 5. 5, 12, 13 is probably the next most common one. We also see 6, 8, 10 a lot, which is really just this doubled. So if you know these, you kind of have some shortcuts, but a lot of these questions don't involve common ones. We'll even see radicals at times. We'll see problems that have complicated radicals or expressions. So you need to be able to do the Pythagorean theorem with radicals. You need to be able to do it with expressions. But you'll need to a lot of times do it with just very basic numbers here. And if you don't remember 3, 4, 5, you can still do the Pythagorean theorem, 3 squared plus 4 squared equals x squared, and go through the process. 9 plus 16 is x squared, 25 equals x squared, and so we do the square root, and that's why our missing side here is 5. All right, well, how about this one? We see the legs are 3 and rad 7. So this is not a common one, so I'm definitely going to have to think about this theorem here. 3 squared plus rad 7 squared equals x squared. I should really be using parentheses. And so 3 squared we know is 9, but how about rad 7 squared? And you could actually type that in your calculator, but it is 7. And there's two ways to think about why rad 7 squared is 7. One is rad 7 times rad 7 would be rad 49, and the square root of 49 is 7. That's one way to think about it. The other is square root squared kind of undoes each other. Doing the square root of something and squaring it are like opposite sides of the same road or opposite sides of the same coin. It's kind of like plus 3 minus 3 or times 5 divided by 5. Times and division, plus and minus, square root and squared. They undo each other. So the square root of a number like square root of 7 squared is just 7. Equals our x squared, and 9 plus 7 is 16 equals x squared, and so x here equals 4. Okay, it's not always going to be a nice answer like 4 or 5. Sometimes we have something like simplest radical form. We'll see here. 2, 4, 5 is not true. 2, 4, 6 is not true. So we got to actually do this one out here. 2 squared plus 4 squared equals x squared. That's 4 plus 16. It's an ugly plus sign there, sorry. 4 plus 16 is x squared. 20 is x squared. So x equals the square root of 20, and we need to be able to reduce radicals in simplest radical form. So you think about two numbers that multiply to 20. There's 20 and 1, 2 and 10, 4 and 5. But one of the two numbers has to be a perfect square. 1 is a perfect square, but it doesn't really help because you still have 20. So 4, 9, 16, 25, those are your perfect squares. And 4 works here. 4 times 5. 4 is the perfect square, 5 is not. Now, so we do the square root of the perfect square, and that goes outside. The number that's not a square, the 5, that stays inside. Your calculator cannot reduce radicals for you, but it can check them for you. You could type in rad 20 in your calculator and 2 rad 5 in your calculator, and you'll see that they do match. So you could always do that. Sometimes you're finding a leg here. So it's not always finding the hypotenuse. So it would be x squared plus 5 squared equals 13 squared. And this one you might actually recognize as 12. That's one of your common ones, 5, 12, 13. But of course, you could do the algebra out to see that as well. All right, these next two are a little challenging. This one's another radical expression, but it's got a number in front, so let's see what that has to do. Plus, we're finding a leg, and that's probably the best way when you, first of all, how do we know it's Pythagorean theorem? You know, are the directions going to say use the Pythagorean theorem? They could, but probably not. You know it's a Pythagorean theorem when you're working with a right triangle. It has to be a right triangle. If it's not a right triangle, you're not doing the Pythagorean theorem. You're doing much more complicated trigonometry. So if it's a right triangle and you have 2 out of 3, you can find the third. Now, if we're missing 2 sides, you can't do Pythagorean theorem. Or if you're missing all 3, can't do Pythagorean theorem. But if you're missing only 1 and you have the other 2 and it's a right triangle, then you know Pythagorean theorem's coming up. You know, we saw that a bunch when we were doing, you know, rhombuses because the diagonals were perpendicular, which formed the right triangles and stuff like that. So anytime you see perpendicular side lengths, you know, you want to have Pythagorean theorem on the back of your mind, and there's a good chance it's going to come up. So the legs are x and 2 rad 6. So x squared plus, definitely going to use parentheses this time, 2 rad 6 squared equals 7 squared. And what's this come out to be? Obviously, I know this is 49. Well, it's not as simple as what we had up here with rad 7. Rad 7 squared was just 7. And rad 6 squared is 6, but the 2 in front makes it a little bit more complicated. What you have to remember is that anytime things are next to each other, like 2 rad 6, that means they're being multiplied. Just like when you see 2x, that really means 2 times x, right? When things are sandwiched right next to each other. So this is 2 times rad 6. And so what we need to do is square both of these things separately and still multiply them together. So the 2 that's out front, the radical, that's not a radical. That's just the number 2 being squared. And the number 2 squared is 4. Then we have rad 6. And rad 6 being squared is 6, because a radical squared, you get the number inside. Like rad 7 squared was 7. And so then we have 4 times 6 is 24. Once again, you could actually type that into your calculator. If you open a parenthesis, do 2 rad 6, close the parenthesis, you might have to close it twice, and then squared, your calculator will confirm it's 24. But you should understand why. Square the number in the front, square the radical, which just gives you the number in the radical, multiply them together. And so this is where we're at. And so then we can subtract the 24, get x squared equals 25, and x equals 5. Last one, and this one involves some expressions. I have legs here and here. So 15 squared plus x minus 2 squared equals x plus 7 squared. 15 squared is 225. No problem there. But now we get expressions squared, and this is actually a special type called a binomial squared. And we'll see this come up maybe once or twice in geometry, a few times, and it shows up on the Regents occasionally. But this is a skill that comes up constantly next year in Algebra 2. So this is something you're going to be doing almost on a weekly basis in Algebra 2. We see it in almost every single chapter. And when something's squared, it's times itself. So it would be x minus 2 times x minus 2. And you can do distribution, x squared times negative 2x times negative 2x times plus 4, right? When you multiply all those pieces. And then combine the like terms in the middle, we get x squared minus 4x plus 4. But there's also a shortcut, which again, you're going to definitely talk about next year in Algebra 2 because you'll do this so often. But here you could just do the long way here. But the shortcut is square the front. That's how we get x squared. And you square the back. That's how you get the plus 4. The middle part's the hard part. And that comes from times each other doubled. So times each other is negative 2x. It doubles to negative 4x. The mistake students make is they think it's just x squared plus 4, or x squared minus 4. It's not. It's always a trinomial. And you can use FOIL or double distribution or different methods, box methods to do this, but it's always going to be a trinomial of the front squared, the back squared, the middle is times each other doubled. So like this one, front squared times each other, 7 times x is 7x, doubles to 14x, and then square the back, we get 49, and 225 here, plus. So you're going to have to do that in this chapter at some point, and you're going to have to do a lot of it in geometry. So we want to set this all equal to one side and solve it through factoring, maybe. Oh, actually, in this case, we're not going to have to. Once I see that x squared, I usually think that, but I have it on both sides, so they actually cross out, so you don't need to worry about that. So let's see, I can not worry about this equals 0 part then. I jumped ahead thinking it was a factoring question and worked out that those x squares cancel out. I can add 4x to this side, giving 20, not 20, blowing it at the end of this video, 18x. And let's see, I have 225 plus 4 would be 229. And hold on, just wanted to grab a calculator so I don't make any more mistakes. So we have 229 on the left side, and then we need to minus 49 over to that side, making it 180. And now the algebra is pretty simple here. I could divide 18 and get x equals 10. So you're going to have to do Pythagorean theorem with radicals, with expressions, finding sides, finding legs. Don't forget your common triplets to help you save some time. And that's the Pythagorean theorem, and we'll practice that, of course, tomorrow in class.